Myself, Akhilasri. Today my seminar topic name is different types of events. First one, we have to discuss the definition of an event. An event is defined as a set of possible outcomes of an experiment. It is a subset of the sample space. Example, experiment, rolling a die, sample space. It is denoted as capital S, equals to 1, 2, 3, 4, 5, 6. Let event A getting an even number. From the total possible outcomes, we have only 3 even numbers. That means 2, 4, 6. Now we can discuss the different types of events. First one, discrete event. Second one, continuous event. Third one, certain event. Fourth one, impossible event. Fifth one, mutually exclusive event. Sixth one, equally likely events. Seventh one, exhaustive events. Eighth one, favorable events. Ninth one, equality of events. 10th one, independent events. 11th one, dependent events. Now we can discuss about different types of event in detail. First one, discrete event. A discrete event is an event related to a discrete random variable, meaning the outcomes can be occurred finite or countably infinite. Example, tossing a coin, A equals to getting a head. Second one, continuous event. A continuous event is an event related to a continuous random variable where outcomes can take any value within interval, but it's not countable. A continuous event is we can take some specified points only. It is a so the example, student's height is between 150 to 160 centimeters. And second example, measuring the time taken to run a race. Now third one, certain events. A certain event is an event that is sure to happen when a random experiment is performed. Its probability is always 100% because it is sure event to happen. So it is also called as a sure event. Example, when rolling a die to getting a number from 1 to 6, that means if you have to roll a die, we can getting a 6 numbers. So it is a sure event. So the probability of an sure event equals to 1. Probability of certain event is always 1. Fourth one, impossible event. This event is inversely proportional to the certain event. An impossible event is an event that cannot be happen when a random experiment is performed. So its probability is 0. For example, rolling a die and getting a 7. That means if you have to roll a die, they only getting a 6 numbers. There is no getting greater than 6 because the die has only 6 numbers. So A equals to 0. And fifth one, mutually exclusive events. Two events are called mutually exclusive if both cannot occur at the same time in a single trial of an experiment. They have no common outcomes. Example, let event A is equals to even numbers, event B equals to odd numbers. A intersection B is 0. That means in even numbers there is no odd numbers and odd numbers there is no events. They do not have no common elements. So A intersection B is 0. that situation the event is said to be an mutually exclusive events. And the sixth one, equally likely events. Two or more are said to be equally likely if each has the same chance, that means probability of occurring. Probability of all outcomes are equal. Example, tossing a fair coin, getting a head or tail. Each probability has 1 by 2. That means if you have to toss a coin, there is getting a 2 chances only, either head or tail. So each probability has the same chances. That means each probability has a 1 by 2. And seventh one, exhaustive events. A set of event is exhaustive if together they cover all possible outcomes of a random experiment. The collection of all possible outcomes. Example, rolling a die, that means 1 to 6. Eighth one, favorable events. The outcomes in the sample space that satisfy the condition of an event are called favorable outcomes. For example, rolling a die. Let event A getting a number less than 4. That means if we have to roll a die, we getting a number from 1 to 6. That means 1, 2, 3, 4, 5, 6. But the given event A is getting a less than 4. So from total possible outcomes from 1 to 6, they have only 3 chances for less than 4 to getting less than 4. That means 1, 2, 3. So the favorable outcomes are 1, 2, 3. The total favorable outcomes is 3. And next one, equality of events. In a given sample space, two events are called equal if both events have the same elements. That means, for example, let event A equals to 1, 2 and event B equals to 1, 2. Then A and B are equal number of elements. So that events is said to be an equality of events. If A and B equal elements, then A equals to B. And tenth one, independent events. Two events are said to be independent if the occurrence of one event does not affect the occurrence of the other. Example, tossing a coin and rolling the dice. Let event A getting a head on the coin and event B getting a 4 on the dice. That means, for example, let event A getting a head on the coin. If you have to toss a coin, they have only 2 chances getting a either head or tail. They have no choice to getting a number. So event A is to be happen but does not affect to event B. As well as if you have to rolling a dice, they have only 6 to getting a 6 numbers. So they do not get either head or tail. So event B is also a not effect to event A. That means these two are independent events. That's why in case of independent events, two events are said to be independent if the occurrence of one event does not affect the occurrence of the other event. So because the coin result does not affect the dice result as well as the dice result does not affect the coin result. And 11th one, dependent events. Two events are dependent if the occurrence of one event affects the probability of the other. Example, drawing cards without replacement. Event A, first draw is red. Event B, drawing a king on the second pick. That means after the first card is taken out, the deck has fewer cards, so the second probability changes. Thank you.